Hey everyone, welcome back. Today we are going to talk about something you absolutely need to understand if you are working with microservices, and that's the database per microservice pattern. It's one of those core concepts that helps you avoid data chaos as your system grows. We're going to walk through what database per microservice pattern means, why it's important, and how it plays out in a real e-commerce platform, from browsing products to placing an order to making a payment. Let's get into it. So imagine you're building an e-commerce system, and like any good architecture these days, you are going with microservices. You've got a product service for managing inventory and product info, a cart service to handle items users add to their carts, an order service to actually place the order, and a payment service to handle transactions. Each one is small, focused, and independent. That's the beauty of microservices. Now here's the question. Where do they store their data? Should all these services talk to the same central database? It might sound convenient, but that's where things go wrong. Let's say all your services use one big shared database. Now your product service has its own tables. So does the cart service. Same with orders and payments. But since it's one database, nothing is truly isolated. One service could accidentally modify another service's data, or maybe you change a schema for one table, and suddenly another service breaks, even though it has nothing to do with that feature. You also end up with tight coupling. You can't scale services independently, you can't deploy them separately, and now you've got teams stepping on each other's toes, waiting for database migrations to finish. This is exactly what the database per microservice pattern solves. So what is database per microservice pattern? With database per microservice pattern, every microservice owns its own database. Fully, the product service talks only to its own database. The cart service, same. The order and payment services, they each get their own isolated database too. This creates a clean boundary. One service can't directly access another service's tables even if it wants to. If the product service changes its schema, that change has zero impact on the other services. This gives each service the freedom to evolve, scale, and deploy without waiting on others. Let's go step by step through how this works in your e-commerce system. A customer browses the store. The front end calls the product service to fetch a list of items. The product service pulls product data from its own database, things like name, price, and stock. Next, the customer adds an item to their cart. The cart service gets that request. It doesn't ask the product service for permission. It just adds an entry to the cart table in its own database, storing product ID and quantity. Now, the customer clicks checkout. That triggers the order service. The order service pulls the cart items from the cart service, but only via an API call. It doesn't access the cart database directly. It creates a new order in its own database and calls the payment service. The payment service handles the transaction and logs the payment in its private database. At no point does one service reach into another service's data layer. They communicate via APIs or events, but they never share the same database. So why is this so helpful? First, it isolates failure. If the product service's database is down, it doesn't bring down the order or payment services. Second, it helps you scale. Let's say the cart service is getting hammered with traffic. You can scale just that service and its database. No impact on the rest of the system. Third, it makes development faster. Teams can work on their services independently. They don't have to sync on database migrations or fight over table locks. You get cleaner code, fewer bugs, and more flexibility. You might be wondering, what if two services need the same data? Let's say the payment service needs product pricing to confirm the final amount. In a monolith, you'd just join two tables. But in microservices with separate databases, you don't do joins. Instead, the payment service would either call the product service API to get the price, or listen to events like product price updated and keep a local copy of that data in its own database. This is called data duplication for autonomy. You copy just what you need and keep services decoupled. Yes, it's a little more effort, but it keeps your system clean, modular, and resilient. So to sum it up, the database. Per microservice pattern means every service manages its own database. No sharing, no cross-service queries, no accidental coupling. It helps you isolate failures, scale services independently, and move fast without tripping over other teams. Thanks for watching, and I will see you in the next one.